Hi, Assalamualaikum. My name is Muhammad Mustaqim bin Rosman Rizal. My metric card number B0919103881. I am from BMMH. Okay, today I will present about equivalent resistance and delta star conversion. Okay, for the introduction, what is resistance? Resistance is a measure of the opposition to the current flow in an electrical circuit. Resistance standard unit is ohm. Resistance measurements are normally taken to indicate the condition of a component or a circuit. The higher the resistance, the lower the current flow. When the lower the resistance, the higher the current flow. We move to the resistor. Okay, a resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuit, resistors are used to reduce current flow, adjust signal level to divide voltage, bias active element, and terminate transmission lines, among other use. In a resistor, the voltage V is proportional to the current I, which the constant of proportionality are known as the resistance. Okay, we can use the Ohm formula, that is V equal to I times R, and then I equal to V per I, R equal to V per I. Okay, this is the example of the resistor. Okay, each color represent certain value, and for this, and the 10% means that actual resistance is between 900 k ohm and 1.1 m ohm. Okay, we move to the circuit. There are two circuits, that is series and parallel. For series, it will be look like this, and for parallel, they will be look like this. Okay, this is the voltage formula. If you want to find V in for series, that will be V in equal to V1 plus V2 plus V3, and for the parallel, V in equal to V1 equal to V2 and equal to V3. Okay, for the current formula, if we want to find I, that will be I series. For the series will be I1 equal to I2 equal to I3, and for the parallel, I in equal to I1 plus I2 plus I3. Okay, this is the resistance formula. If we want to find the R equivalent or R total, that will be R1 plus R2 plus R3. This is for the series. And then for the parallel, 1 per R equivalent is 1 per R1 plus 1 per R2 and plus 1 per R3. But this is it for the condition if there are 3 or more resistor. But for if in the circuit only have 2 resistor like R1 and R2, we can use this formula. Okay, the formula will be R equivalent equal to R1 times R2 per R1 plus R2. Okay, for this topic, we'll be using this formula, the R equivalent. Then we move to the example of the circuit reduction. This is the example. First, if we want to settle this circuit, we must first solve this series circuit like this. We can plus 1 ohm plus 5 ohm, that equal to 6 ohm. Then for the parallel, we can use the formula, that will be 6 times with 3 and per 6 plus 3, that will be equal to 2, and the circuit will be look like this after we have solved. Then, like the previous slide, we also will solve the series first. Then will be 2 ohm plus 2 ohm equal to 4 ohm. Then when we get the series, we will be use the parallel formula for the R equivalent. Then there will be 4 times 6 per 4 plus 6, that will be 2.4 ohm. Then the circuit will be look like this. This is the final circuit. Then we can solve this by using only series formula. Then it will be like this. R equivalent equal to 4 ohm plus 2.4 ohm plus 8 ohm. Then the answer will be 40.4 ohm. That for the R equivalent. Then we move to delta to Y transformation. Okay, the delta to Y transformation is an extra technique for transformation certain resistor combination that cannot be handled by the series and parallel equation. We will be used this technique if the circuit cannot handle by the series or parallel. Okay, the network for delta will be look like this. There is triangle and rectangle. Then for Y network we will look like this, Y and T network. Okay, then this is the formula for if we want to change from delta to Y. We will be use this formula. Okay, first what we want to find is R1, R2 and R3. Okay, for R1 there is RB times with RC and divide by RA plus RB plus R6, and then for R2, RA we times by RC and divide by RA plus RB plus RC, and then we move to R3, that will be RA times RB divide by RA plus RB plus RC. Okay, and then after we have the circuit will be look like this from triangle to Y. Okay, this is the example for the calculation. If we want to transform delta to Y network, okay, this is the delta network, and we can see here. Okay, then we let RA equal, we take 10 ohm, and RB we take 30 ohm, and RC we take 60 ohm. Then by using the formula we will be get R1 equal to 80 ohm, R2 equal to 6 ohm, and R3 equal to 3 ohm. And okay, the last network will be look like this. This is the final answer. Okay, then we move to Y to delta transformation. In this case, we must find RA, RB, and RC. For RA, the formula will be RA equal to R1 times R2 plus R2 times R3 plus R3 and times by R1 that divide by R1. Okay, for RB, this will be same, but we will be changed for R2, and then RC will be used out R3, and then this is the example for the Y to delta network. This is the Y network that we will be changed to delta. Then this is the calculation. First, we may let R1 equal to 10 ohm, R2 equal to 50 ohms, and R3 equal to 20 ohms. Okay, by using the formula, will become like this, and we will get RA 170 ohms, RB 34 ohm, RC and 85 ohms. The final answer will be become like this. This is the delta circuit, the triangle shape. Okay, that's all. Thank you.